Hi friends, so in this video we are going to create a linked list of n nodes. The language I'll be using here is C programming language. Well, I could show you the algorithm also, but I think it would be very useful if we look how it works in programming, like how in program using programs we can create a linked list of n nodes and dynamically grow its size. Okay, so let's follow some. Actually, we have a lot of hash include to first include like hash include studio.h. Don't worry if you are unaware of this. This is just the basics of C. For different programming language, you can have the different syntax. So since we are following C, so first we need to include some libraries like hash include studio.h, then hash include. You might have heard if you are aware of using C language. So this is hash include conio.h and then hash include allocate. This is an important library for allocating the memories for our nodes. Okay, so these are not very much important to our point of view, but these are the certain libraries, important libraries if you are using the C and if you want to create a linked list of n nodes. So keep that in mind. Okay, so now we know we have this node structure, and for this node we have two parts. One part will store our data, another part will store the address of the next node. Okay, so this is the node. Now this node is a kind of structure, right? So in C, in other object-oriented programming languages, we have different kind of classes we make, like to store data. But in C, we don't have classes, so we have the structure. So that is why we can store this in structure, right? So let's create a function called void create node. Okay, so this void create node will definitely be used for creating node. We are just defining the prototype here just to make use this function later. Now we have to create a structure for this node because like this is not a kind of normal integer. The data type is not normal like integer or float or something like that. So we need to create a structure for that. And for creating structure, we have this syntax struct node. Okay. And within the struct node, we are defining the contents, what we want. We need one data. Data would be an integer type data, of course. For right now, we are considering integer. And then we need a pointer that will store the address of the next node. So definitely we need a pointer known as next that will store the address of the next node. And this pointer would be of struct type, struct node type. Okay. So struct node pointer. I'll So there is a data of integer type, and then we have a struct node pointer because this pointer will store the address of a node with whose type is a struct node. Okay, so that is why. And next. So this is the structure of the node that we'll be using. Then after that, we will be defining the type def struct node. We will be defining a node. Okay, and for the node we are going to certainly have a head. So node pointer head equal to null. So initially for the linked list we don't have the data element, so we will be putting the head pointer as null. So head is also a node which contains the address as null. Okay, so what we did right now is we created a struct node. Okay, node a structure of type sorry a node of type struct, and inside that we declared what we wanted, that we wanted an integer type data type, and we wanted a pointer that will hold the address of another struct node. So struct node pointer next. Is that clear, this part? Now we are defining a node. Okay, so we are defining a struct node. I mean, this node is the name and it is of type struct. Okay, and then we inside the for the node we are having a head pointer, like we are defining a pointer that will hold the address of the node, and that is null. Okay, so you'll get used to of that. Now in the main we would like to call the create node function based upon the number of nodes that we have to create. So int I n, and we need to know from the user what how many nodes we want. So printf enter the number of nodes that we want to include in the linked list. Okay, then in the scanf we will be getting the node percentage %d. So these are just will be different for different programming languages. So we will be getting the number of nodes, and then we will start a loop for I equal to 0, I less than n, I plus plus, and for each time we will be calling the create node function that we have already defined as the prototype. Not defined, we have the prototype as, and catch, and we'll end this. Okay, so this is our main function where we are taking how many nodes we have to create, and based on that we are calling the create node function. So every time the create node function will be called, it will create one node, and we have defined the structure of the node. This is the structure of the node, and then we have declared a node, and we have declared the head pointer that will hold the address of the node. Okay, so this is a head pointer of type node that is currently holding null value. Now our main function will come, that is void create node. Okay, so this create node function is important. Here we will be creating the node. So initially for creating the node, we have for every time like from for n nodes, for every time we will be creating the node. So the very first time if we are creating the node, we need to have the data element. Okay, so that we'll be getting. And for creating the node, we need two pointers, right? We have one pointer already, that is node pointer head, and that contains the null value. So this is already present, but for creating node also we need to have the two pointers, right? So let's create the two pointers, node pointer temp and another node pointer q. So these are the two pointers of type node. Clear? It is very easy. Now in the temp, for the temp we are allocating some memory location. So we will use the malloc function for that. So the way of allocating memory to this is node pointer malloc, and we are specifying the size of node. The size of node will definitely come from the struct part. So node pointer, we are allocating a type node pointer, then malloc, and then size of node. Okay, so this for this now we are creating a node, a temp. Okay, and inside that temp now the node has been created. So for the next we are placing null. Now we have to place that data. So printf enter data element. We are taking the data element from the user. So enter data element. Then we have the scanf, and then we are entering the data percentage %d, address of, okay, temp of data. So inside the temp of data, we are taking the data, and temp of next is set to null. So we are just creating a node here. We are putting the next as null, and then we are entering the data into it. Okay. Now, now we'll check that if our linked list is empty or not. So initially our head will be null. So we are checking that whether there is any node or not. So if head equal to null, then definitely it is the first time we are going to create the linked list. So we will be placing head value as the temp. Okay, we'll be updating the head pointer as temp, and then we will be moving forward, like the head will be pointing to the first node, and the first node will have the next pointer as null. But if already we have created some of the data, like we have already a linked list with the head pointing to some node, then definitely the head will contain the address of the node already there, right? So what will we do? We already have the temp pointer. So we'll place the value of head into another pointer q, and we will move our like already we have one node here. Let's suppose we have this node here, and this is null already, and this has the value data, and the head is pointing to this 100 address. Okay, now we have one new node that we have created, that is temp, and this has the value 200. Okay, it has the data. No, it's just a new node. Now we want to put here 200 so that we can connect a link to this. Okay, so for that, what we do, this is our temp. So automatically we will have to update the head as a head will be 100 only. Okay, we will have to update the head next of head, right? So what we'll do, like for the q, we will put the head value to q, and now it is not necessary that it is only the first node. It could be the condition, like we have two nodes as well already there in the linked list, right? We are on to the third node. The newly created node is the third node. Okay, so and our head will be always pointing to the first node. Okay, so this is our head pointing to 100, and this is the already created node 200, and let's say our temp is this and it has the address 300. So what we need to do, we need to traverse until we are getting the null here, right? Here we are getting null, but we have to traverse onto the nodes until we get the null pointer here, and then we will have to update the temp pointer, temp address into this. Okay, so we place the head value as q because we can't move the head. The head will always point to the first node. Okay, so q as head, while next of q is not null. So while this is true, we will be moving the q as q equal to next of q. Now, when we will get the next of q as null, will come out of this while loop. And what then we will do? We will then update q next of q equal to temp. Okay. So what we will be doing, we will be updating the temp value into the next of q, right? And then we will conclude because the temp already has the null. Now what we'll do, we will include the temp equal to null, and q equal to null. This is an important thing to note because uh, of course we have these two pointer. This shouldn't be pointing somewhere to the memory location unnecessary. Okay, so this is the thing we can do. So we already have put the data here, and we are just updating the pointer in this if else part. Is that clear? So this way we can create a linked list for n nodes, right? So is that clear? I think this is important to note. We the node creation, and then we are creating the struct, and then putting the head null, and in that we are calling the create node function. The create node function is important. We are having these two pointers because one is for creating the node, the temp is for creating the node, and q is definitely for traversal because we can't move the head from the first position to another position. So it's just a dummy pointer we have created so as to traverse the link until we are getting the next as null. For temp, we create malloc node pointer malloc and size of node. We assign the next as null to that because we won't be pointing to another node from temp. We are entering the data into it. Okay, and then we are checking if there is only one node, then of course the head will point to temp. If it is not, then we are moving the queue until we are getting the next of queue as null. In the next of queue, we are placing the temp value because we want to grow the linked list, and then we are it's just because we don't want to unnecessary pointers pointing to some memory location, so we are placing null to them, and this way we can come out. So in this way we can create a linked list of n nodes. Okay, important things are these two. You need node to node because the node will be of structure type and it will have int data and another pointer of struct node type. Okay, because it will be containing the address of another structure type node. Okay, so this is important, right? Apart from that, everything is easy. We'll look into some more other creation of node and insertion and deletion part in the upcoming lectures. So this was all about it. Thank you very much.